first thing is we will remove the cover. Once the cover is removed, this reveals the resolver rotor, which is inside, as well as the stator bus bars. So these corresponds to each phase of the stator winding. What we will do is we will test each of the bus bar terminal with continuity against the casing. These should be perfectly insulated from the casing, and if any part of the stator is shorted, there might be a chance of continuity between the casing and each of the terminals. If you do have continuity, that is bad. We are not supposed to have any continuity between the casing and each of the terminals. In theory, in the best case, if you have access to an isolation meter, usually you can get a used Fluke one to help you with the process. You can also test isolation between each bus bar terminal and the casing of the MGU. You can use 80 volts or 100 volts range or even 200 volts range to test isolation. And what we'll also do, because most people don't have an isolation meter, we can also use a multimeter to test for resistance in the kilo ohm range. And what we should see is a very high resistance, almost too high for it to conduct. So to diagnose the stator, first we will test for continuity. Rather than saying testing for continuity, we're actually testing for isolation. So this is the casing of the stator. This should not have continuity. This should be perfectly insulated. If there is continuity anywhere throughout each of the terminals against the casing, we know that the stator is shorted. Okay, this has no continuity, which is a good sign. Next, we will test the resistance. This shows 4.0 mega ohms, 3.9 mega ohms, which is a very high resistance. This is the acceptable amount of isolation value. Now we move on to the next terminal, 3.4 mega ohm, and then the next terminal, 3.2 mega ohm. 3.2 mega ohm is a very high resistance value, which is acceptable for a 48 volt motor generator unit.